Hi, good afternoon, everyone, or good morning if you're listening to this from America. And welcome to this webinar on ROC Wind Farm Operations, boosting production thanks to automation. First of all, I wanted to thank to all of you who have joined us today in this webinar because it's actually one of the first webinars that Green Eagle Solution is organizing by its own. And we are quite amazed by all the professionals and people who have registered for this webinar and who has shown their interest on this topic, which is automation. So I introduce myself. My name is Paula Canto, and I work at the Business Development Department. And I'm mostly in charge of the corporate communication and marketing strategies of the company. And I will be moderating today this session. And with me is Jorge Lopez, who is a business developer also at Green Eagle Solutions, and he forms part of the ARSOS analysis team. So he will be speaking later on how automation is increasing revenues in a specific remote operation centers from a company which is RWE, the former Innogy. And well, before getting into the matter, I wanted to remind to all attendees that you will be mute the whole session, but at the end of this webinar, we will have a questions and answer session where we can discuss any questions that you might have. So during the webinar, you can already type any questions that you might have. And I think you can find this question and answer section at the bottom of the screen. Mm, Moreover, during the next days, you will also receive an email with this presentation and with the recording of the webinar. So what we will be talking about today is something that most of you are concerned about and probably are already trying to achieve. And this is how automation, how can we take a bit more out of our wind farms? I mean, how can we do to make them more profitable? And the most important thing is which tools are out there in the market that we can use to achieve this. Mm, Well, before going through the main topic, which is automation, I wanted to briefly present the company, Green Eagle Solutions, for those of you who are not familiar yet. And well, Green Eagle Solution was founded in 2012. The headquarters is in Madrid, where the board of directors and the business development department team is. And then in Seville, we have what we call the technology hub. And here they work the software development team. And also we have our own control center there from where the service team gives support to our customers. So Green Eagle Solution, as many of you already know, is a software company. We are specialized in the wind energy and also solar energy industry. And we mainly help our customers in the areas of monitoring, analytics, and especially the remote control of their wind farms or solar farms. And we do all this through our main platform, which is ARSOS. And nowadays, this platform is connected to more than 6,000 megawatts spread out in different countries, as you can see here in America, in Europe, like Germany or UK, and then also in Asia, in the Philippines and Indonesia. Well, I would like to start this webinar showing the structure of the platform that I just mentioned before, ARSOS. And ARSOS stands for Automated Renewable Smart Operations Software. This technology uses automation to operate wind farms and improve their operational processes, allowing these power plants to produce more energy and therefore to get more revenues. But in order to apply the intelligent control to operations, we must start with the integral monitoring, what we call the integral monitoring that you see at the base of the pyramid. This is basically the digitalization and monitoring capabilities that ensures the data collection and its quality and its integrity. And then once we got assured this level, we would go to the to what we call integrated analytics, that it's related to the analytical needs. Here we provide with a fully compatible tool where wind farm owners or operators can get operational insights. I mean, they can quantify energy losses, analyze in general the wind farm performance. But as I said before, it's fully compatible with other analytical tools that you may be already using at your remote operation centers. And then once we have these two levels, we can go to the top and introduce the intelligent control module, which is our hallmark. At Green Eagle Solutions, we have been always betting on operational automation. And in order to efficiently apply this intelligent control, we must add value throughout the entire data value chain. So this means guaranteeing its collection, extracting value through analysis tools, and then all this knowledge, once we got all this knowledge, it can be applied or it can be transferred to the operation protocols using the automation capabilities. Once I have already explained the main capabilities that our platform has, I wanted also to introduce a bit the context where we find ourselves in, and in which we can see certain macro trends which are shaping the evolution of our sector, and how these trends are having a direct impact on wind farm owners and operators. So first of all, in this graph that you can see here, taken from IRENA, there is a clear downward evolution of the levelized cost of energy, and this has a direct consequence on the operation of these plants and in the need of increasing the revenues. So to have a better understanding of the wind energy prediction, here we can see a couple of graphs taken from Wind Europe, where they show us the cumulative installed power in Europe in 2020 and the forecast for 2025. How does this exponential growth affect to our sector? Well, it's great news, of course, that wind energy keeps growing, but this has a direct impact on control centers. They find themselves in the position where they have to operate a portfolio with more and larger wind farms. And on top of that, they have to deal with more diverse technology too, in terms of the type of turbine they manage. So following the data on the pie chart at the right of the slide, and taking into account what we just commented before about the variability of today's portfolio, at the end of 2020, more than 28,000 megawatts in Europe are between 15 and 20 years old. And to finish with the context as a third input in one of the trends that we can find in our sector today, we see in this graph, also taken from IRENA, the evolution over the last 12 years of the average prices of operation and maintenance under full service contracts. And what this graph represents, it's a clear price adjustment, a clear adjustment in business margins, and as a consequence, a reduction in margins along the entire value chain of our sector. So after seeing the behavior of the market, Green Eagle Solution has identified three main operational challenges. And the first one, it's increasing revenues. owners nowadays, they have the need to increase their revenue somehow, because since the LCO is decreasing, profit margins are getting thinner and thinner. The second main challenge would be scalability. And this is because operators at the remote operation centers, they have to deal with larger portfolios and portfolios with larger dimensions. And on top, diversity in their technologies that they have to deal with. They have the need to increase their management capabilities, but at the same time, they don't want to increase the operational cost, which is something totally understandable. And the last challenge would be the need of applying intelligence to operations. There is a need to adapt to the increasingly complex wind farm conditions, and also to take the opportunity to adapt to new environmental restrictions or new market trends, which require the application of different commercial strategies, for example. So to solve these challenges that I just mentioned, what RSO's software gives are two main technical improvements, the ones that you can see here at the left side of the presentation. And the first one would be quicker and smarter response time. The second technological improvement would be the implementation of multiple strategies. And this is possible even down to a wind turbine level. And these two technological improvements encompass three main economic benefits to both owners and operators. So the first economic benefit is the fact that it increased asset availability, production, and revenues by cutting down the response time and consequently increasing the time-based availability of any wind turbine. And the second economic benefit, it's related to the scalability, meaning that there is an increase of the ROC capacity, of the remote operation centers capacity. This is possible by avoiding the operators to perform repetitive tasks, and they can focus more on other customer added value activities, such as performance analysis or other operation support tasks. And last but not least, we would find the optimization of maintenance costs, the increase on maintenance savings. And thanks to the automation, the software guarantees that all assets will be operated in the same way, following strictly the operation protocol. And this, it will be done independent of the operator's condition, expertise, or capabilities. And this derives into optimizing future corrective maintenance. So now Jorge is going to go deeper into these benefits, and he will use a real case study of RWE. But however, and with his permission, here is a little spoiler, because we have calculated that using RSOs, any wind farm can increase on average 1% of its availability, and also can increase his ROC capacity by 5. So Jorge, the stage is yours, and you can go on and present this real case.
Thank you very much, Paula, for the introduction, and hello to everybody. The first thing I wanted to do is to thank all of the attendees for coming today to watch our webinar on automated operations in wind farms. And going straight to the case study that Paula was mentioning just a few minutes ago, I wanted to explain to you the situation on how we started working with RWE. So around August 2020, we started speaking with the operational director of RWE's control center in Barcelona, which is Antonio González. And he told us what their major challenge was at the moment. RWE was thinking of doubling the portfolio size operated from their control center. And at the moment, they were operating 470 wind turbines, which add up to 500 megawatts installed power. But they were looking to increase to 1 gigawatt, including all of their Italian fleet of wind farms. So what they told us is that they were facing a scalability issue where they'd have to introduce more people into the team in order to operate double the installed capacity. At that point, we thought that we had the answer thanks to ARSUS and its automation technology, and that has been proving up to today. So what we did is we started working with 2 wind farm pilots. So we introduced these 2 wind farms into the ARSUS platform, and we started operating with the automation technology. And what we found out is that it actually did work, and it did cut down times and therefore increased availability, which is, as Paula said, the first main benefit of using ARSUS. So then RWE took the decision to implement ARSUS in the whole Spanish fleet, and we did that from November to January 2021. And once they had proven that it also worked for a large portfolio of 500 megawatts, they decided to expand to the Italian fleet, and nowadays we're almost finishing to integrate all of the wind farms in Italy with great success. I also want to tell you that most graphic material that I'll be showing from now on in the presentation corresponds to this specific wind farm, which is a very beautiful wind farm in the area of Soria, Spain, composed of 59 wind turbines, which are up to 47.2 megawatts. They are Gamesa Made technology, and they are operated by our RWE using our automated operations technology called ARSUS. So going straight to the first technological improvement that Paula was mentioning, quicker and smarter response time. Okay, so why quicker? So what we do when we start working with a customer to integrate ARSUS as their automation technology to operate a wind farm is we ask them for the operations protocol that they were using from their standard control center at the moment. We code and automate the operations protocol, and then ARSUS start running and acting immediately upon every incidence of any wind turbine of the wind farm. Actually, ARSUS has a maximum response time of 5 seconds, which we can consider immediate if we compare it with the average response time in standard control centers, which is around 20 minutes. We have agreed upon this number with our client RWE after they had done an analysis on what was the efficiency of their control center. And they said that sometimes this number could be much greater, sometimes lower, and they agreed on a 20 minutes average response time upon incidences. So what I want to show you first is a summary of how ARSUS worked operating this wind farm automatically from September to February 2021. At the top of your screen, you're seeing right now a summary of events, which is being directly registered from the wind turbine signals of alarms and events. And at the bottom, you can see the summary of actions that ARSUS performed over turbines during this time span. What kind of actions? You see a blue bar and red bar. The red bar corresponds to the notifications. And what are notifications? Well, when an alarm triggers in a wind turbine and there is no possibility to remotely restart the wind turbine, or it is not recommended by the operations protocol, then most of the times the recommendation is to notify an on-site technician. And this is something that ARSOS does immediately, applying, as I said, the standard operations protocol. And then we have the other kind of actions, which are resets, and these are the most interesting. Resets are the reset commands that we send to the wind turbine in order to get it up and running again, or at least the attempt to reset the wind turbine. And you can see here that over 2,500 notifications were done over the time span of 6 months, over 4,200 resets, from which 300, 500 were successful reset. And what is considered to be a successful reset? Well, I'll go deeper into this in a few minutes, but let me just say that a successful reset is defined as a reset after which the alarm that triggered the wind turbine stop is no longer active, and that the turbine successfully restarted and resumed power production without falling into the same exact alarm within the next 10 minutes. In the graph below, we have also plotted with a green line the average wind speed during the resets. And as you might have noticed, the number of actions performed by ARSOS is directly related to the average wind speed. This means that ARSOS acts mostly when there is a high wind resource, which is very interesting. And the next graph will help me demonstrate you so. Okay, so this graph now shows a distribution of the actions performed by ARSOS, which we saw before over a timeline, this time related to the wind speed, which is in the bottom axis. We have also plotted the turbine's theoretical power curve in red in order to see where and when ARSOS acts most. The light and dark blue bars are a count of resets and successful resets, as we defined them before, correspondingly for each 0.5 meters per second wind speed slots. And we quickly draw a promising conclusion from this graph. ARSOS automated actions happen mostly during high wind resource episodes, meaning that if the turbines were resetted immediately upon incidences, they started producing again. Even more, the turbine would have had a high load factor if it were to be activated as soon as the alarm triggers. And this is what ARSOS does. Every time that the operator's protocol recommends a reset attempt upon an incident, ARSOS immediately tries so as a human operator would do in a perfect world. And in fact, the turbine starts producing again. Let me note that in the case where your wind farm is located in an area with high average wind speeds and where the market price is higher than the average 40, 50 euros per megawatt here in Spain, and I know that these can rise significantly in other countries, but most importantly, wind farms subject to other revenue schemes such as PPAs or feed-in tariffs with a higher price per megawatt hour. Every single time that ARSOS is restarting your turbines immediately, there is a huge volume of revenues that you're currently not profiting from. And we're speaking of remote resets here, which please note that had a over 83% success rate. But actually, we mentioned notifications before, and this applies exactly the same for notifications to on-site technicians. Actually, as you can see in this graph, again, a huge part of these are done while there is a high wind resource, and it is critical to alert technicians as soon as possible so that they do what is stipulated by the protocol to get the turbines back running again. And one last thing regarding quicker and smarter response time, this time focusing on the smarter part. The quicker response that ARSOS provides once you've coded the protocol and it's being applied automatically allows us to analyze this data. And there is an unleashed power of analyzing automated actions that I'm going to try and translate to you. As I said, once you know that alarms are being monitored and acted immediately upon, you're capable of analyzing what is really happening upon each and every incident, and most importantly, without the operator's reaction time affecting the data. So this is what we are doing in terms of analysis, and this is partly why we call them intelligent operations. This here is an example of the kind of table that we're generating as an analysis of our operations. For each event, what we're doing here is we are recording its success rate in resetting the turbines, but we're also recording all relevant data from the wind turbines at the same time that the incidents occurred and during all of the reset attempts. What this does is it allows for further analysis and deeper understanding of what is really happening. For example, let's look at the table's first row. Say that error 155 here is an error related to high wind speeds and turbine vibrations, for example. Well, we now have the following information. How many times was this rule executed, and what was its success rate? And let me clarify here that a rule is defined as the set of attempts to reset a turbine and to erase the active alarm. So one thing is looking at what was the success rate of the rules, but we should also look at how many reset attempts occurred and what was its success rate. But even more, maybe the error was finally erased by the rule and the turbine started producing again. But did we try to reset it too many times? Maybe we tried to reset the turbine too soon, or maybe even with not enough time between attempts. If we analyze the data and we draw valuable conclusions, these, the time between attempts, or how soon we're trying to reset a turbine since the alarm is active, are all parameters that we can modify within the automated operations protocol and then progressively improve the operational efficiency of the protocol, reducing as well the turbine mechanical stress when trying to reset it. And let me go one step further. What if we look at the meteorological data, for example, during the errors? This graph here shows in green the reset attempts to solve a high vibration problem, whilst the red bars represent the unsuccessful resets. The blue line is the average wind speed during this, and what we found out looking at a graph like this and the data that we are gathering is that the most part of the unsuccessful resets happened when the wind speed was above a certain threshold. And therefore, the right decision to make was to introduce this variable in the automated operations protocol and only restart turbines when below that threshold. This immediately increased the success rate of the reset rules and consequently reduced future expenses in corrective maintenance of gearboxes, for example, due to high mechanical stress during the resets. I know, excuse me, I know that this is not the main topic and the main focus of this webinar, but I did want to express you the importance of having an automated operations protocol and the great value of analyzing reliable data. In any case, we will be organizing a webinar in the near future to speak exclusively about this, and rest assured that you will be personally invited so that you can attend in the case where you're interested in hearing more about this. Moving on to the second technological improvement, RSOS renders operations smarter in just another way. The capacity to implement multiple strategies for different wind farms, the same single wind farm with different operation protocols, or even down to turbine level. This itself is a value proposition for all those owners who face the need, or rather have the desire, of operating their assets with diverse objectives, such as, for example, prioritizing asset exploitation to its maximum, or rather applying lifetime extension programs, or operating assets depending on external factors such as market price or environmental restrictions. And let me explain this a little further. Once the operations protocol is being applied automatically, the potential of optimizing the protocol is of huge dimensions. As I mentioned before, we can analyze the reliable data drawn from RSO's automatic operation, but we can also introduce other variables into the protocol, namely internal and external data. Let me explain. A human operator obviously has a limited capacity to check a certain number of parameters before sending a control command to a wind turbine. However, RSOS goes beyond human capabilities and has the capacity to check an infinite number of variables upon every incident before acting on a turbine. These variables could be internal, meaning that they come from the information the local SCADA, such as wind speed, setting it as a threshold for an action to be performed, as we mentioned before, or wind direction, the active power, the active primary and secondary alarms, or even taking into account main component status, such as, for example, the oil temperature in a gearbox. But also external data, such as weather forecast, energy market price, or environmental restrictions. And actually, I'd like to note that some of our clients are using RSOS with this goal. For example, there are wind farms which operate depending on the market price, restarting turbines only when the market price is above a certain level, which is the calculated average cost of maintenance of the wind turbines per hour. And also in France, we're working with, by the hand of a huge European IPP, and we have implemented RSOS to comply with acoustic restrictions within the new country's policies for renewable power plants, as well as for BETS and BATS environmental restrictions, and the compulsory curtailments to comply with. RSOS automation has a direct impact on the wind farm's availability. And this is the most important and main economic benefit of this technology. By acting immediately, we are cutting operational downtimes and therefore gaining time-based availability. Let me illustrate you with a simple graph to explain this. In this graph, the blue bars are the number of successful resets performed by RSOS, which, taking into account the hypothesis that an operator would have taken an average of 20 minutes to act upon, sums up 20 minutes of time during which the turbine with the active alarm could have been working. Each bar is the sum of the successful resets performed each day, which you can see had a maximum of nearly 200 in one single day. And each one of them are 20 minutes of a wind turbine working, whereas if operated following the dynamics of a standard operations control center, they wouldn't have been working for an average 20 minutes from the moment that the alarm triggers. If we add up all of this time, we get the accumulated line in red, which represents the progressive increase in time-based availability throughout the 6 months, ending up with a total increase of 0.5% of time-based availability. And this is directly traduced into more production and therefore more revenues. In the second place, the second economic benefit is scalability. And how is RSOS increasing ROC's capacity? Well, mostly during high demand or stress periods. And what I mean here is that the machine can outperform human, especially when there is a high demand of actions to be performed over a huge portfolio of wind turbines. And this mostly happens when there are extreme weather conditions, when simultaneous alarms trigger in different OEM technologies, which you have to monitor and control from different interfaces. Also, when you have to apply complex protocols where you might have to check multiple parameters before acting on a turbine, and also taking into account turn shifts, the experience of the operator, and its constancy, which will never meet the constancy of ARSOS when it's automating the operations protocol. Some of you might have recognized already the image to the right. This is an image taken from a satellite after the so-called Filomena storm that struck Madrid and other regions of Spain with unprecedented snows. And what I wanted to show you is what happened during these 2 days of storm in the control center of Barcelona of RWE. And this is the data for Aldehuelas, the wind farm that I presented you before, as during the whole presentation. But just for this wind farm, during the time span of 2 days, we can see the average wind speed plotted with the red line, wind speeds that got up to 20 meters per second and were very constant during almost 12 hours. And what we can see is that operators would have suffered a great demand and a great stress of acting upon a great number of wind turbines, especially, for example, at 3 a.m. in the 22nd of January, where up to 80 actions were performed between notifications and resets. And what I want you to note here is that not only ARSOS allowed the control center to notify all of the on-site technicians, but that all of those resets, which were successful, and this was in an 80% success rate, made the turbines start working again when there were very high average wind speeds, and therefore the production load factor was not negligible at all, actually very important. And taking into account what ARSOS can do in periods of high demand, let's see what happened from September 2020 to February 2021, and what is the result if we add up the sets of 20 minutes gained in operations that the human operators from RWE's ROC didn't have to perform, and it rather was ARSOS that did it automatically. If we add up all of this time, we get more than 2,200 man hours that were saved thanks to performing automatically more than 2,500 notifications and more than 4,200 resets. And the ultimate result of this is that now, once that we've integrated ARSOS into the operation of their whole new portfolio, they have had the opportunity to double their ROC's capacity without the need of hiring any more full-time employees. And once again, not only that, but all of these notifications, all of these actions which were successful resets, were adding up availability of the wind turbines and therefore production and revenues for the owners. Finally, the last economic benefit is the increase in maintenance savings thanks to the safety that ARSOS provides in operations. Actually, we believe that ARSOS will become an insurance for operators, an insurance that the technology is going to be able to check an infinite number of variables and act always in the same way upon any incidents in the wind farms. Actually, here to the right, we can see a logic architecture for one of ARSOS protocols. And what you see is various different loops where the technology is continuously checking different parameters and asking if it should or should not act towards a wind turbine. So this is a level of safety that a human operator can't meet. And actually, RSOS has the capacity to check on parameters such as status of communications, the working schedule of on-site technicians, their availability, and major components which might be in quarantine periods. So the important thing to say here is that RSOS can be your insurance that you are operating your owners, your owned assets or your clients' owned assets exactly as the protocol describes. And this is very important because you're always going to meet the maximum availability for these wind farms without having to pay extra attention to a specific wind farm or a specific OEM technology that is more problematic. This obviously taking into account more parameters and acting correctly upon any incidents is a future saving of maintenance costs due to the corrective maintenance that must be done over turbines that have not been operated as good as they should have been and that have suffered extra mechanical stress, for example. Well, knowing that RSOS is doing exactly what it should do is an insurance that there will be savings in the future in maintenance costs. And just to finish with the case study, here below we have the number of how much RWE calculated is going to save over the time span of 1 year in this 1 gigawatt operated portfolio. And it's due to the three main benefits that I mentioned before. Firstly, the increase in availability, production, and therefore revenues, and this is clearly the most important. But secondly, as well, due to the scalability and the increase in the ROC's capacity and the capacity of operators to not be actively monitoring and acting upon turbines, but RSOS is doing it automatically. And finally, the savings, the increase in savings due to not having to perform certain corrective maintenance in the future. This all adds up to 582,000 euros per year. And this is a number that we have agreed upon with our client RWE, and they have confirmed that this technology works, that it is useful, and it is greatly profitable for the ROC. Just before I finish, I wanted to show you the actual platform. I wanted to show you what any of you would be seeing if you were using RSOS from your control center to operate your assets. And this is the smart control overview. At the bottom, we have the RSOS turbine overview where we can see the status of the wind turbines, whether they are on fault, being curtailed, or the system is okay. Also fundamental parameters, and at the right you can see the geo operations protocol is what tells us what operation protocol is being used for each and every wind turbine, having also the capacity to change to manual control at any moment. But the most interesting part are the two sections above. To the left, we have the last actions done. Here, what we can see is what has been done in the last hours by RSOS and how it's resetted, notified, or tried to do any action on your assets. And even more interesting is the section to the right, which is RSOS upcoming actions. And this is RSOS telling you what it's programmed to do in the next few seconds, minutes. And this could be executing a first or second attempt to reset a wind turbine, a notification to an on-site technician, etc., etc. The thing here is you always know what RSOS has done and what it's going to do next. And to the most right, you have an image, an example of how the on-site technicians would receive the notifications of the actions that RSOS has performed, or the notification of an active alarm that they should manage. Just before I finish, I wanted to show you RSOS revenues calculator. And let me just say that this is available at our website, www.greeneaglesolutions.com. And let's do an exercise where you imagine yourself using RSOS and how much you could earn using this automation technology. I have created a client hypothesis here for a portfolio of 200 megawatts, assuming a 0.7% availability increase, which we have already spoke about. This can go up to 1% on average. And this is a reasonable number once we've calculated the average availability increase across the whole portfolio that RSOS is acting upon right now. Let's also assume a price of 70 euros per megawatt hour, whether it's in the market or through a PPA or a feed-in tariff price. Let's also assume wind farms with an average 2,500 full load hours and a 20 minutes response time, which we mentioned before could be higher for some standard control centers. Well, if this were to be your case, thanks to RSOS, you'd be earning 245,000 euros in the time period of 1 year, meaning that after 4 years, you'd be profiting for 1 million revenues thanks to using the automation technology, cutting downtimes, increasing turbines availability, and therefore wind energy. That's all from my part. I hope that you've all enjoyed the presentation. And Paula, we're now open for the Q&A section.
Thanks a lot for bringing us this result today, because I mean we can see with real numbers the potential of these new technologies like automation. So thanks a lot. So well, the first question here is how is this solution installed? Any hardware needed in the wind farm?
Okay, yeah. So in most of the cases, the answer here is going to be no. Why? Well, Green Eagle Solutions has been working for years with different OEM technologies, and our capacity to connect with the OPC server or the equivalent standard communications protocol that your local SCADA system is using is of great value. And this is how we are able to connect with cloud-based architecture communication systems. There is, however, situations where you might need to have hardware on-premise, such as, for example, I know that in USA, there is a need to have on-premise servers installed, I think both in wind farms and control centers in order to operate wind farms. And we also can do this. We have, say, service where you acquire the hardware equipment and we'll give you all the remote support so that you can install it, bringing the costs to minimum. But most of the cases, we're going to go with a cloud-based solution where all of the data is stored on cloud and everything is up and running without the need of hardware equipment.
All right. So there was a second question that says how much this solution cost. Here I would say that well, usually there is a setup cost for the integration of the power plants in the software, and it is a negligible setup cost, especially in those cases where the solution is cloud-based. And then there is a recurrent fee since the software is a SaaS solution. And this fee is directly related to the number of megawatts. So that means euros per megawatt. And I don't know, if Jorge, if maybe you can illustrate us here with a real case.
Oh, I'd just like to add that given that, as Paula said, the setup cost is almost negligible. The revenues start from the first month, the first day that you're using Arsus. There is no high costs directly related to the integration of wind farms into the Arsus platform, and therefore the revenues that you're gaining thanks to the increase in availability of wind farms starts from day one, and this is the case for all of our customers.
Okay, so oh, there is another question that we just got. It says, so for what I have understood, I can apply different protocols in the same wind farm. Is it true?
Yes, exactly. I'm glad that you understand that correctly, because yes, not only can we apply different protocols for different wind farms, which is what you actually do in a standard operations control center nowadays, but once that we've coded the standard operations protocol, we can define other operation protocols depending on the time period of the year, depending on certain thresholds or values of parameters that you're checking before deciding what operations protocol to apply. As I said before, you can focus this, for example, towards maximizing the exploitation of the asset. But maybe it's the case that you want to apply a life extension program to your wind farm, or even to certain wind turbines within your portfolio. So you can program Arsus to apply different operation protocols for not only the same wind farm in different situations, but also for different wind turbines within the same wind farm.
All right. I have seen that there is a question in the chat, and it says, will each client has their own tenant in the cloud for data protection for the clients?
Yes, thank you very much for the question. I don't. I think what we're speaking here about is how is the cloud-based infrastructure. So yes, what we're doing here is we're using Amazon Web Services to create the cloud space where we're working, and Green Eagle Solutions has a standard set of procedures to guarantee cybersecurity, and we usually do this through VPN tunnels. So what we're doing is we're extracting all of the data from the local on-site servers or the local SCADA system. Through VPN, we're uploading all of this in real time to the cloud, which is a reserve space for each of the clients, guaranteeing the security of their data. And then that's the space that we're using for them. And it could rather be us who manages the space in Amazon Web Services, or in the case that we're speaking about deploying this solution in your own control center, then maybe you desire to manage your own Amazon space. That can also be done. In any case, what I can assure you is that your portfolio is separate from the rest, and the data protection is guaranteed for all of our clients.
Thank you, Jorge, for your answer. Well, it's almost 5 o'clock and there is no questions left so far. So I think we can say goodbye and thanks to all of you for attending this webinar and for being here with us today. As I said at the beginning, you will receive the presentation and recording of this webinar through email. And I hope that soon. I see there's a last question, but unfortunately we are running out of time. So we will answer to this question personally through email. All right. Thanks a lot, as I said before, and I hope to see you soon in the next Green Eagle Solutions webinar.
Thank you, everybody.